Welcome to the lesson on types of waste. Upon completion of this lesson, learners will be able to define waste and recognize the main sources of waste, including transportation, inventory, motion, weighting, overproduction, overprocessing, and defects. Learners will also discuss solutions to eliminate common causes of waste. Waste is the use or consumption of any resource that does not add value to the product, or in other words, any non-value added activities. Any money, time, materials, or natural resources that are put into the manufacturing process and do not improve the quality of the product are considered waste. The elimination of wastes and inefficiencies is sometimes called MUDA. Toyota identifies the 7 principal types of waste as those associated with transportation, inventory, motion, weighting, overproduction, overprocessing, and defects. We will discuss these types in the upcoming slides. The first source of waste is transportation, which refers to the unnecessary movement of a product or material. Since the transportation of a good rarely adds value to the product, any transportation is typically considered waste. Poor facility layout, product flow, large batch sizes, and large storage areas can cause transportation waste. As a rudimentary example, let's say the cost of transporting a box 50 feet is $2 because of the forklift operating cost and labor cost. Now let's say that the cost of moving the same box, but only 10 feet, is $1. The company saves $1 per box. An even better way to reduce the forklift cost would be to eliminate the move altogether. An example of transportation waste at an EV facility could be the unnecessary movement of battery packs between multiple stations or storage areas before assembly, which does not add value to the product and increases handling time. Inventory is one of the most significant waste sources in lean. Excess inventory is typically an indicator of overproduction. Inventory is costly because of the space requirements, labor, and equipment needed. For example, let's say you're making parts that aren't selling as quickly as they're being produced. The finished parts that haven't been sold yet begin to clutter the production floor, so you decide to build a storage facility. To move the goods from the production floor to the storage area, you may need new equipment and people to operate it. Then, you need to hire people to track, manage, and maintain the storage area. Costs are quickly adding up. Plus, adding an inventory operation increases the risk that goods are damaged. When a product is in inventory, the company is spending money without seeing revenue from that product. Excess inventory can be caused by poor demand forecasting, miscommunication, or just the fear of running out of a product. An example of inventory waste at an EV facility is the storage of excess EV motors and batteries without orders, which ties up capital and consumes valuable space. Let us take a quick look at the 3 types of inventory: raw materials, work-in-process materials, and finished goods. Raw materials are the primary materials purchased to manufacture a product. In EV manufacturing, a few examples include lithium, cobalt, nickel, which is essential for producing EV batteries, and aluminum, which is commonly used for constructing lightweight, durable car bodies. Next is work in process, abbreviated as WIP inventory, which includes semi-finished products that are still in the production phase. For example, in EV manufacturing, battery cells that are partially assembled and waiting to be integrated into the battery packs represent WIP inventory. Then we have finished goods, which refer to the final product ready for sale or delivery. This includes the fully assembled EV, which is ready for customer delivery, charging units sold separately as accessories, etc. Disadvantages of large amounts of WIP inventory include increased lead times, poor flow, buildup and clutter on the production floor, and tied-up profit, which is the company's profit that cannot be used immediately. The third source of waste is motion, which is the unnecessary movement of machines and workers, and this is separate from transportation waste. Transportation waste refers to the movement of goods and materials. Motion waste, on the other hand, is the non-value added movement of people or machines. Motion waste can be caused by inefficient facility layout, flawed interface between workers and equipment, poor workstation layout, poor organization, and work processes that aren't standardized. An example is a technician assembling EV battery modules who walks several meters to retrieve torque wrenches from a distant tool station. The fourth source of waste is weighting. Waste due to waiting occurs when any materials, goods, or workers are left idle, usually because of waiting for the next step in the production process to begin. In traditional batch and queue manufacturing, a product spends the majority of its life waiting to be processed, as you can see in the image shown here. Poor material flow often increases waiting. Linking processes together and improving bottlenecks can reduce waiting. Waiting can be caused by unexpected breakdowns or maintenance issues, long changeover or setup times, and problems passed down from upstream processes. Imagine a scenario where a technician is waiting for a batch of battery cells to finish testing before proceeding to the next step in the assembly process. During this time, they are unable to advance with their tasks or take on other work, resulting in a delay in the production flow. Overproduction is the fifth source of waste. This occurs when products are produced in excess or ahead of demand. This is one of the most common sources of waste in manufacturing. Overproducing parts is risky because the company loses money when a part is finished but cannot be sold. To avoid overproduction, it's essential to produce at the rate of actual demand. Overproduction also results in higher inventory levels, occupying valuable resources and space. Long process setup times, large batch sizes, and poor communication cause overproduction. Overproduction also occurs when companies have a just-in-case mindset. An example includes an EV battery assembly line that produces more battery packs than required for the current production cycle. The excess units may need to be stored, leading to inventory overflow and added handling costs. Overprocessing, the sixth source of waste, occurs when goods and materials undergo processing steps that do not add value to the product. Examples include painting unseen areas or overpainting, unnecessarily tight tolerances, and cleaning or polishing beyond required levels. Essentially, any effort put into a good that does not increase value is overprocessing. Overprocessing is sometimes caused by poor communication and poorly interpreted customer requirements. More commonly, overprocessing happens as a quality assurance measure. Although additional and repeat operations can prevent quality issues, they are only beneficial when needed. Defects, the seventh source of waste, are the result of products that do not meet customer specifications. Defects are wasteful because inspection, rework, rescheduling, and scrapping are costly activities. Scrapping a product means that any raw materials, processing, and labor that have been spent on the part up to this point was a waste. If defective parts reach the customer, even more labor may be needed to deal with complaints and correct the order. Defects are usually a significant portion of a company's costs and can be caused by poor equipment maintenance, poor process or product design, misunderstanding of customer requirements, operator errors, and little or no process control. An example of this type of waste is a batch of battery packs produced with faulty connections due to improper welding. These defects demand rework or scrapping, resulting in wasted materials, labor, and energy during production. Let us shift focus to some of the potential solutions to tackle each kind of waste. Transportation waste can be eliminated through several key strategies. Organizations should optimize their facility layout to minimize the distance between related processes, reducing unnecessary movement of materials and products. This can be complemented by implementing point-of-use storage systems, where materials and tools are stored directly at workstations where they're needed rather than in central locations. For larger operations or facilities with high material handling volumes, automated material handling systems like conveyor belts, automated guided vehicles, or robotic systems can be considered to streamline transportation and reduce waste, though these solutions should be carefully evaluated based on cost-benefit analysis and specific operational needs. Inventory waste reduction relies on just-in-time, abbreviated as JIT delivery systems that bring materials only when needed for production, coupled with Kanban systems that provide visual signals for replenishment at predetermined minimum levels. Better demand forecasting through data analytics enables precise inventory planning, while vendor-managed inventory programs allow trusted suppliers to monitor and replenish stock automatically, optimizing inventory management. Motion waste can be eliminated through targeted ergonomic assessments that optimize workstation layouts for efficiency. Tools and materials should be placed within easy reach of operators, following ergonomic principles. Visual management systems clearly mark where items belong, preventing confusion and wasted movement. Standardized work processes help eliminate unnecessary movements by defining the most efficient sequence of actions. Weighting waste reduction requires balanced production lines that eliminate bottlenecks, supported by cross-trained workers who can provide coverage during absences. Regular preventive maintenance minimizes equipment downtime, while visual signals enable quick communication of production status across operations, ensuring smooth workflow without delays. Overproduction waste can be minimized by implementing pull-based production systems that manufacture items only in response to customer orders, rather than pushing products based on forecasts. Large batch sizes should be broken down into smaller, more manageable runs, while improved production scheduling ensures output matches actual demand patterns. Overprocessing waste is reduced by reviewing and eliminating non-value-added steps while clearly defining quality requirements with customers. Processes should be standardized to prevent variation, and appropriate technology should be deployed to match the task requirements, avoiding overly complex solutions for simple operations. Finally, defects waste can be eliminated by implementing mistake-proofing or poka-yoke devices that prevent errors from occurring and establishing quality checks at the source of production. Statistical process control provides ongoing monitoring of quality metrics, while comprehensive operator training ensures consistent understanding and application of quality standards. In summary, eliminating waste is a key focus of Lean. The 7 sources of waste are transportation, inventory, motion, weighting, overproduction, overprocessing, and defects. Each source of waste has common causes for which businesses may design solutions to minimize, reduce, or eliminate. Thank you.